Alright guys, so we are continuing to have a goal without these few videos about evaluating integrals using U substitution. Now, we've gone through a handful of examples already, and the purpose of these next few videos are going to be the exact same thing. Just get us used to looking at some different types of possibilities and how to use U substitution properly. In this particular example, we are going to be looking at some possible trig identities having to come up in the midst of our integral evaluation. So let's take a look here. The integral of cotangent 7x. So you might be thinking to yourself right off the bat, okay, trig functions, I can take an antiderivative of a trig function, no problem. But think about it for a sec. We don't have an integral, a function whose derivative is exactly cotangent. And so that presents a little bit of a problem for us. However, if you think about what cotangent is, cosine over sine, then we might be getting somewhere to get an opportunity to substitute something that also has an existing derivative within the integral as well too. So let's think about this for a sec. Cotangent of 7x, this is the same thing as saying, hey, this is the integral of cosine of 7x over sine of 7x dx. Well, why am I going this route with it? Well, think about what you could possibly do here. You want cosine of 7x dx to be represented in du. How do I know that? Well, because you know that du has to be the multiplier, the product of some function times d of x. It's going to be a challenge for us to get this to happen if we made it, if we tried to make du in some way represent a function of sine. So what we're instead going to represent as u is going to be a function of sine. That way du is a function of cosine. So we're going to make u sine of 7x, thus making du in this particular example 7 times the cosine of 7x dx. Okay? So let's continue to think about this. I have to have a 7 in my du. That means I need to account for that somewhere in my integral as well. And so, just like we've been doing in the past, let's rewrite this as 1 over 7 times the integral of 7 cosine 7x, and I'll put the dx up top, just so we can literally see that we're about to completely substitute that entire numerator out of there with du. So let's take a look. Now 7 times cosine of 7x dx, that is our du, and sine of x was u. So swapping out our u's, we are now going to be getting the integral 7 cosine of 7x is du over u, because u was sine of 7x. Gosh, now hopefully I hope that is looking extremely familiar to you. I'll rewrite it like this if it helps you on out even more. Now it's 1 over u times du. Well, what's happening here? 1 over u, we know that integral. That is the natural log of u. So, we will now go ahead and look on into what this looks like. Alright, but I don't want to forget my 1 over 7. I'm getting excited here. I'm forgetting my 1 over 7. So my 1 over 7, now this becomes 1 over 7 times the natural log absolute value of u plus c. We're going to keep that absolute value in there because we don't want the negatives, alright, coming on into play. Now, 1 over 7 times the natural log of u. Well, this really is 1 over 7 times the natural log u, alright, with sine of 7x, and then plus our constant of integration. Alright, ladies and gentlemen, I want to give you one to give a shot on your own since we didn't on the last example specifically. So, let's take a look at try this one on out. So, you are going to be evaluating tangent of 4x plus 2, and you are going to see that your that your integral is going to be, let's put dx here. Your answer when this is all said and done will be negative 1 over 4 natural log of the absolute value of cosine 4x plus 2 plus c. Alright, give that one a shot, see if you're on the same page, and on to the next one.